resistors in parallel and series combination. Resistors in series or parallel, whatever you call, right? So in first series combination we discuss Rs is equal to R1 plus R2 plus R3. So grouping of resistors more than one becomes the combination. So here in this case, in parallel case, 1 divided by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 we discuss, right? After that one we are going to move EMF. So here, before we are going to move, so we are going to discuss cell battery circuits, right? Now see here, cell. So cell is a source of EMF. It is a source of EMF. So I wrote here, it is a source of EMF. So EMF the source, cell. Clear my point? Right. So then what is battery? It is a source of EMF consisting number of cells. See here, if suppose we are going to consider, right? So now this part is called what? Battery. This part is called what? Battery. Clear my point? This part is battery. Correct? So one day EMF ಅಥವಾ cell cell. Clear my point? It is cell. This one day cell. Clear my point? So the number of EMFs, it is the source of EMFs. Sorry, number of cells. So many cells. So battery. We are going to call battery. It is a source of EMF. Consisting number of cells. So EMF is source in a cell and cell battery. Right. After that, see here is circuit. So then what is the circuit? So here it is a combination of EMF, right? Electrical components, sum of resistors, capacitors, connecting wires. So ನೀವೆಲ್ಲ ಕಡೆ ಏನು ಮಾಡ್ತೀವಿ, ಒಂದು ರಿಮೋಟ್ ಬಿಚ್ಚಿರಿ, ಒಂದು ಮೊಬೈಲ್ ತಗೋರಿ, ಇಸ್ತ್ರಿ ಪೆಟ್ಟಿಗೆ ತಗೋರಿ, ಬೇಕಾದ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಾಮಾನು ತಗೋರಿ, ಅದರ ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಇರ್ತೈತಿ, ರೈಟ್? ಸೊ ಹಿಯರ್ ಸಿ see, this is here resistor, this is capacitor, this is potential difference, right? Or EMF. So this is key. It is key. So key is the very important in our circuit. Key is the very important part of our circuit. So here combination of resistors, capacitors, voltages, right? What keys? So all the combination of the components is called as a circuit. Circuit. Clear my point? So it is a combination of EMF. So what? Electrical component, R bandre, C bandre. So then such as resistors bandre, capacitors bandre, right? Connecting wire bandre, connect wire bandre. These are all called combined in this what we call circuit. Adenanta karithive circuit anta karithive. Idu gottagirಬೇಕು. So ಇದು cell, ಇದು battery, ಇದು circuit. It is a source of EMF. EMF ಒಂದು source ಗೆ ಏನಂತ ಕರೀತಾರೆ? Cell ಅಂತ ಕರೀತಾರೆ. Right? So ಇಲ್ಲಿ consisting the number of cells, ಬಹಳಷ್ಟು cells ಇದ್ವು ಅಂದ್ರೆ ಅದಕ್ಕೆ ನಾನು ಏನಂತ ಕರೀತೀನಿ? Battery ಅಂತ ಕರೀತೀವಿ. Right? Clear? After that, here EMF. What is EMF? So ನಿಮಗೆ ಇದರ definition ಗೊತ್ತಿರಬೇಕು. EMF. Here EMF is also called as electromotive force. See here this EMF is the potential difference between positive and negative electrodes. Positive and negative electrodes of a cell. Positive and negative electrodes positive and negative electrodes of a cell in an open circuit. So that is when no current is drawn from the cell. No current is drawn from the cell. For example, see here. Don't get confused here. Here this is a resistor, external resistor, right? So this is what? Cell. This is a cell, right? Here, see, in this case what happens? There is a potential difference is there. That the potential difference between the positive and negative electrodes of a cell in an open circuit. See, if I am going to mark the dot here, now the key is closed. First of all, this is the symbol of key. This is the key symbol. This is key symbol. This key symbol is open key. Clear? So if I am going to dot here, the key is what happens? Closed. This is closed. Hanga bittandre open key. ಇದನ್ನ ಡಾಟ್ ಇಟ್ಟದೊಳಗೆ ಕ್ಲೋಸ್ ಅಲ್ಲಿ ಗೊತ್ತಾಗ್ತದೆ ಪ್ರಾಕ್ಟಿಕಲ್ ಮಾಡೋಕೆ ಓಪನ್ ಅಂಡ್ ಕ್ಲೋಸ್ ಇರ್ತದೆ ಅಲ್ಲಿ ಏನಿರ್ತೈತಿ ಓಪನ್ ಅಂಡ್ ಕ್ಲೋಸ್ ಇರ್ತೈತಿ ಸೊ ಇದು ಕೀ ಸಿಂಬಲ್ ರೀ ಈ ಕೀ ಸಿಂಬಲ್ ಒಳಗೆ ಡಾಟ್ ಇರಲಿಲ್ಲ ಅಂದ್ರೆ ಕೀ ಓಪನ್ ರೀ ಡಾಟ್ ಇತ್ತು ಅಂದ್ರೆ ಕೀ ಕ್ಲೋಸ್ ರೈಟ್ ಸೊ ನಾವ್ ಸಿ EMF is the potential difference between so EMF ಏನೈತಲ್ರಿ ಅದು ಏನಿರ್ತೈತಿ potential difference between positive and negative electrodes of a cell. ಈ ಸೆಲ್ ಒಳಗೆ ಏನು ಪಾಸಿಟಿವ್ ಮತ್ತು ನೆಗೆಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಅದಾವಲ್ರಿ ಆ ಏನು ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಅದಾವಲ್ರಿ ಅದರೊಳಗೆ ಸೆಲ್ ಇನ್ ಆನ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಆಫ್ ಎ ಸೆಲ್ ಇನ್ ಆನ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಅದು ಹೆಂಗಿರ್ಬೇಕು ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಇರಬೇಕು. ಸೊ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಅಂದ್ರೆ ಸೊ ದಟ್ ಈಸ್ ವೇರ್ ದೇರ್ ಈಸ್ ನೋ ಕರೆಂಟ್ ಫ್ರಮ್ ದಿ ಸೆಲ್. ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಕರೆಂಟ್ ನ ತೆಗೆಯಕ್ಕಾಗಲ್ಲ. ಕನೆಕ್ಷನ್ ಇರೋದ್ರಲ್ಲಿ ಕೀ ಹಾಕಬೇಕು, ಕೀ ಹಾಕಿದ್ರೆ ಕರೆಂಟ್ ಬರ್ತದೆ ರೈಟ್. ಏನು ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಆ ಪಾಸಿಟಿವ್ ನೆಗೆಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಸಿಗ್ತದಲ್ರಿ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ electromotive force or EMF of the cell. EMF of the cell, right? For example, look. Right? Chemistry. So this is electrolyte solution. So these two are called electrodes. These two are called what? Electrodes. Here this is what? Minus anode. So this is called what? Plus, that is cathode. Right? So here, see, in these two I am going to connect external source. So here, whatever the potential difference between these two, electrodes in an open circuit, you know, in the electrolyte solution there is no current. In this circuit. So when we are going to current or we are going to measure the current, now when we current measure ಮಾಡಬೇಕಾದ್ರೆ we have to what? Connect the voltmeter to measure the current. Now ಈ current ಅನ್ನು voltmeter ಮಾಡಿ ಕನೆಕ್ಷನ್ ಮಾಡಬೇಕಾಗ್ತದೆ. current ನಾನು ಏನು ಮಾಡಬೇಕಾದ್ರೆ measure ಮಾಡಬೇಕಾಗ್ತದೆ. Right? So here see this electromotive force means means what? Charge. Motive means what? Motion. Force means what? Force. Giving a force. Right? ಇಲ್ಲಿ ಚಾರ್ಜ್ ಅನ್ನು ಇದು ಏನು ಮಾಡಂಗಿಲ್ಲ, ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಂಗಿಲ್ಲ, ಉಳಿಸಂಗಿಲ್ಲ. ಈ ಚಾರ್ಜ್ ಅನ್ನು ಮುಂದೆ ಹೋಗಕ್ಕೆ ಏನು ಮಾಡ್ತಿದೆ, ಫೋರ್ಸ್ ಮಾಡ್ತಿದೆ, ಮೋಟಿವೇಟ್ ಮಾಡ್ತಿದೆ. ಸೊ ದಟ್ ಈಸ್ ದ ಸೆಲ್. Getting my point? So that is called EMF. EMF, electromotive force. Electromotive force. So it is the some definitions. The definition is like EMF is the maximum potential difference between. Maximum potential difference between positive and negative electrodes of a cell in an open circuit. ಯಾವಾಗಲೂ open circuit ಒಳಗೆ ಏನಾಗಲಿ, there is no current. There is no current. ಅಂದ್ರೆ when no current is drawn from the cell, ಈ cell ಇಂದ ನಾವೇನು ಕೊಡಕ್ಕಾಗಲ್ಲ, current ತಗೊಳಕ್ಕಾಗೋದಿಲ್ಲ, because that is in open circuit. That is in open circuit. So this is the point to be noted here. So when the circuit is open, there is no current flows drawn from the cell. Clear my point, right? So this is called EMF. EMF, electromotive force. Electromotive force, right? After this one, see. So here this SI unit of this EMF, SI unit of EMF is volt. ಏನಂತ ತಗೋತೀವಿ, ವೋಲ್ಟ್ ಅಂತ ತಗೋತೀವಿ. ಏನಂತ ತಗೋತೀವಿ, ವೋಲ್ಟ್ ಅಂತ ತಗೋತೀವಿ. ಇದನ್ನ ಈ ರೀತಿ ಇಂಡಿಕೇಶನ್ ಮಾಡ್ತೀವಿ. ದಿಸ್ ಈ ಟೈಪ್ ಏನ್ ಮಾಡ್ತೀವಿ, ಇಂಡಿಕೇಶನ್ ಮಾಡ್ತೀವಿ. ಕ್ಲಿಯರ್? ಸೊ ಇಟ್ ಈಸ್ ಇಂಡಿಕೇಟೆಡ್ ಬೈ like this E, and its SI unit is volt. SI unit is what? Volt, right? So next one here. See here what happened when the same potential difference between the positive and negative electrodes, when the same potential difference between the positive and negative electrodes of a cell in a closed circuit, that when current is drawn from the cell, that is called terminal potential difference. ಅದಕ್ಕೇನಂತ ಕರಿತೀವಿ, ಟರ್ಮಿನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ that is called terminal. ನೋಡೋಣ ರೀಸನ್ ಹೇಗಾಗುತ್ತೆ, ರೈಟ್? Potential difference between the positive and negative electrodes of a cell in an closed circuit. That is when current is drawn from the cell, is called terminal potential potential that circuit what happens, the key is open because there is no current drawn from that cell, right? Whatever the maximum potential difference between the positive and negative electrodes of that cell, clear my point, that is called what, electromotive force. But in this case what happens, whatever the potential difference is there, that is also between positive and negative electrodes of the cell, right? So in an closed circuit, clear my point. So in that closed circuit, so this is once again V, this is R, right? Once again what current is flowing. So in this case, from this cell, the current is drawn. Because the circuit is closed. When the circuit is closed, automatically what happens here? The potential difference between whatever the positive and negative electrodes of the cell and closed circuit. So when the current is drawn from that cell, ಅದರಿಂದ ನಾವು ಕರೆಂಟ್ ಏನು ತಗೋತೀವಿ ಯಾವಾಗ ಕೀ ಹಾಕಿದಾಗ ಅಂದ್ರೆ ಸರ್ಕ್ಯೂಟ್ ಕ್ಲೋಸ್ ಇದ್ದಾಗ. So this is called terminal potential difference. ನಾವು ಕರೀತೀವಿ, right? So here V is equal to IR, right? So can we write here a equation that is current is taking from we are going to discuss in our next equation. Right? I will erase this. So after that one, internal resistance of a cell. This internal resistance of a cell is denoted by small r. See here, this internal resistance of a cell is offered by the what? Electrolyte of the cell. To flow of current through it. See here, what happens? This is capital R, external resistance. This is EMF, right? So this is R. So also it can be denoted as like this. This is small. See the resistance offered by the electrolyte of the cell. Electrolyte ಅಂದ್ರೆ ಗೊತ್ತಾಗಿದೆ. Electrolyte ಅಂದ್ರೆ electrodes. ಒಂದು ಕ್ಯಾಥೋಡ್ ಒಂದು ಆನೋಡ್. ಅವೆರಡರ ನಡುವರ್ಕ ಏನು resistance offered ಮಾಡ್ತಿದ್ದಲ್ಲ, resistance oppose ಮಾಡ್ತಿದ್ದಲ್ಲ. So ಅದಕ್ಕೆ ನಾನು ಹೇಳ್ತೀನಿ internal resistance of the cell. It is defined as the resistance offered by the electrolyte of the cell. Electrolyte ಇಂದ ಏನು ಸೆಲ್ ಒಳಗೆ electrolyte ಇರ್ತದಲ್ಲ ಅದರಿಂದ ಏನು resistance offered ಮಾಡ್ತಿದ್ದಲ್ಲ to flow the current through it. Right? So this is indicated by like this, and here ಈ ರೀತಿ ನಾವು ಏನು ಮಾಡಬಹುದು, ಇದನ್ನ ಗೊತ್ತು ಮಾಡಬಹುದು, ರೈಟ್? ಸೊ ಇದು ಕಂಪ್ಲೀಟ್ ಯಾವಾಗಲೂ ಇದ್ರ ಜೊತೆ ಇರ್ತದೆ, ಬಟ್ ಇಟ್ ಈಸ್ ಆಲ್ವೇಸ್ ಆಡೆಡ್ ವಿತ್ ದಿ ಎಕ್ಸ್ಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಇದು ಯಾವಾಗಲೂ ಏನ್ ಮಾಡ್ತೈತೆ ಅಂದ್ರೆ ಎದ್ರ ಜೊತೆ ಆಡ್ ಆಗ್ತೈತೆ ಅಂದ್ರೆ ಎಕ್ಸ್ಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಜೊತೆ ಆಡ್ ಆಗ್ತೈತೆ. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಗೊತ್ತಿರಬೇಕು, ರೈಟ್? So it is always added in external resistance. ಇದು ಯಾವಾಗಲೂ ಏನು ಮಾಡ್ತೈತೆ, external resistance ಜೊತೆ ಏನು ಮಾಡ್ತೈತೆ, ಆಡ್ ಆಗ್ತೈತೆ. And its SI unit is SI unit is, sorry, internal resistance agane always is ohm, right? That is ohm. It's SI unit. It is ohm, right? So normal again ohm ಗೆ resistance ಏನು ಆಫರ್ ಮಾಡ್ತೀವಿ ಅದನ್ನ ನಾವು ಹೇಳ್ತೀವಿ, right? ಹಾಗಾದ್ರೆ ಟರ್ಮಿನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇದೆ TPD ಅಂತ ಹೇಳ್ತೀವಿ. TPD ಇಟ್ಸ್ SI ಯೂನಿಟ್ ಏನು ಹೇಳಿದ್ರೆ ವೋಲ್ಟ್, ಅದಕ್ಕೆ ಏನ್ರಿ ವೋಲ್ಟ್, EMF ಟು ಏನ್ರಿ ವೋಲ್ಟ್, EMF ಏನ್ರಿ ವೋಲ್ಟ್ ಗೊತ್ತಿದೆ, ರೈಟ್? Here, internal resistor depends on. So, ಯಾವ factors ಮೇಲೆ internal resistor depend ಆಗಿದೆ? First one, so nature of electrolyte. So, a cell ಒಳಗ ಏನು electrolyte ಇರ್ತದೆ ಅದರ ಮೇಲೆ ಏನಾಗಿರ್ತದೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ. Second one, nature of electrodes, right? Nature of electrodes ಮೇಲೆ ಏನಾಗಿರ್ತದೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ, right? So next one, temperature of electrolytes. So electrolyte in the temperature ಏನಿರ್ತದೆ, electrolyte ಏನಿರ್ತದೆ temperature ಏನಿರ್ತದೆ, right? ಅದರ ಮೇಲೆ ಏನಾಗಿರ್ತದೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ. Temperature of electrolytes. So next one is distance between the electrodes. So electrodes ಏನಿದಾವೆ ಅವರ ಡಿಸ್ಟೆನ್ಸ್ ಯಾವ ರೀತಿ ಇರ್ತದೆ, ಎಷ್ಟು ಇರ್ತದೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಏನಾಗಿರ್ತದೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ. ಏನ್ರಿ ನಮ್ಮ internal resistance of the cell. So this is called what? Internal resistance. So these all factors are depends on the internal resistance of the cell, right? So it is defined as the resistance offered by the electrolyte of the cell. The resistance offered by the electrolyte of the cell to flow the current through it. It is always added in external resistance. It is always added in external. External resistance joti add agutade R plus R ಗೊತ್ತಿರಬೇಕು. So ಇದು ಎದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ nature of electrolyte ಮೇಲೆ, right? Nature of electrodes ಮೇಲೆ, next temperature of electrolytes ಮೇಲೆ, next distance between electrodes. All these factors, the internal resistance depends. What depends, right? So after this one, current drawn by the external resistor or external resistor. See here, here. So this is the EMF. So this is the small internal resistance. So here this is what our external resistance. Our external resistance current is going in this direction, right? So see, in this case what happened? E is the total EMF of this circuit, right? So after that, R is the internal resistance. R is the internal resistance. Capital R is the external resistance. Capital R is what? The external resistance, right? See, this is the internal resistance. This is the total EMF, right? So this is the current. This is the what? External resistance. See, here the potential difference is going to be, so two potential differences are there. Two potential differences. See, potential difference across R. So that is V. That is V. Right? Here potential difference across small r is V dash. Right? So now ಗೊತ್ತೈತ್ರಿ ಏನ್ರಿ ಅಂದ್ರೆ ಸೊ ಯಾವಾಗಲೂ ಎಷ್ಟು ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇರ್ತಾವ ಅವನ್ನೆಲ್ಲರೂ ಸೇರಿಸಿದಾಗ ನನಗೆ ಏನು ಸಿಗ್ತೈತ್ರಿ EMF ಸಿಗ್ತೈತ್ರಿ ರೈಟ್ cell is a source of EMF so then can I write now see what V is equal to IR ಬರಿಬೋದ್ರಿ so ಇದು ಏನಿಲ್ಲ ನನ್ನ ಕಡೆ ಇನ್ನೊಂದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಲ್ಲ ಬರೀ ನಾವು ಅಪ್ಲೈ ಮಾಡೋಣ V is equal to IR ಸಿಗ್ತೈತಿ so now see I am going to apply to this R as it is ohm law V dash is equal to I small r ಬರಿಬೋದ್ರಿ next once again here total EMF E is equal to ನೋಡ್ರಿ V plus V dash once again E is equal to V ಅಂದ್ರೆ IR plus V dash ಅಂದ್ರೆ I small r clear my point so once again E is equal to here IR plus R so you better ತಗೋಬಹುದು so here see once again I am going to take I is equal to E divided by R plus R. I divided by R plus R. So this is the current drawn from the external resistance. So E current ಎಲ್ಲಿಂದ ತೆಗೆದಾರೆ external resistance ಇಂದ ತೆಗೆದಾರೆ. Clear my point? ಇದು ಗೊತ್ತಿರಬೇಕು, right? So this is the current drawn by the external resistance. Right? See, in our potential difference, which potential difference? Terminal potential difference. We discussed V is equal to IR. Now see here, can I write V is equal to what is our value of IR? Right? E divided by what? R plus small r. So into what? R. So then can I write here V is equal to ER divided by R plus R. V is equal to ER divided by R plus R. ಬರಿಬೋದಾ ನೋಡ್ರಿ ಈ ರೀತಿ. So potential difference normal line ಆಗಿ ತಗೊಂಡಿನಿ V is equal to IR ತಗೊಂಡಿನಿ I ನಾವೇನು ಕರೆಂಟ್ ತಗೊಂಡಿವ್ರಿ from external source ಇಂದ ಅದನ್ನ ಪುಟ್ ಮಾಡ್ತೀನಿ E divided by R plus R into R plus R. Right? See, suppose if capital R is infinity, what happens? See, V is equal to E infinity divided by infinity plus R. See what happens. So once again, V is equal to E infinity divided by once again called infinity. So then it becomes infinity, infinity, infinity got cancelled. So V is equal to E. V is equal to E. So when the V is equal to E means what? Though because the external resistance is infinity. The external resistance is infinity. So then V is equal to E becomes. V is equal to what? E becomes. V again agati E agati. Right? So what will it be? So if the circuit is open also, then also the V becomes equal to E. Becomes equal to E, right? If R is equal to 0 means, if small r is equal to 0 means, then also V becomes equal to E. R ಯಾವಾಗ 0 ಆಯ್ತಂದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ? V is equal to ಏನಾಗುತ್ತೆ? E ಆಗುತ್ತೆ. ಗೊತ್ತಿರಬೇಕು, right? So this is the current drawn from by the external resistance, and that current is going to be put in our terminal potential difference. We got like this. So tomorrow we are going to discuss about cells. So cells in series once again, cells in or grouping of cells.